the accepted input of any Seaborn function is a data frame. And what's more, if you have, there are a lot of functions, there are a few plots, there are quite a few plots in Seaborn that are hard to replicate in pure matplotlib, but extremely quick and easy in Seaborn. So it's built it depends entirely on matplotlib. And you can quickly and easily create presentation-ready statistical plots with pandas data structures. One caveat, though, Seaborn has some regression functions, but they don't return the parameters needed to assess the quality of the fits. So I wouldn't recommend bothering with any of them. So how do you load and run Seaborn? Well, it depends on the center as usual. HPC2N, in order to get the session to load, you need this combination of modules. At LUNARC, if you're running at the command line, it's this combination, but again, I still recommend that you use like Jupyter or Spider to run some of these, because then it's all included and it's simpler to run the plots that way. Oh, that's still outdated. So that should be matplotlib.use tkag, not tkenter. Tkenter is, at least on LUNARC, it's included with the matplotlib module. And that's the underlying backend. So at HPC2N and at HPC2N, the Seaborn module is separate. At LUNARC, it's also separate. Seaborn 0.13.2 is the most recent version. At UPPMAX, on Rackham, Seaborn is included in the Python_ML_packages 3.11.8 CPU. And again, JupyterLab is available, but Spider is not installed centrally. And if you're on Tetralith, you still have to import that ugly easy build function before you import all of the typical dependencies in JupyterLab. You can install Seaborn locally because it's not installed centrally by pip installing Seaborn to pip install Seaborn, and this should have a -- target equals and then this function. And in all cases, once Seaborn and the module that provides it is loaded, it can be imported directly into Python. In the documentation, you'll typically see it abbreviated as SNS, but for those of us who never watched The West Wing, which is what it's a reference to, I just use SB because that's what I can remember. There are a few common features of all of the pandas functions. For one thing, Seaborn comes with a very handy set of sample data sets, which you can get with the .load or the Seaborn.load dataset function, and that just takes you can view the entire list of available data sets, but a few of the more popular ones are the Penguins dataset, the Iris dataset, Titanic, MPG, and Planets. And the Planets one will hopefully be updated soon. For most of this tutorial, I'm going to be using the MPG dataset, which is about the model year, physical characteristics, engine specs, and fuel economy of a variety of cars from 3 different economic blocks. And for a more categorical data set later, we'll use the Titanic set, which is about the personal demographics, ticket class, and survival status of passengers on the Titanic. There are also a few common features of various plot types. In Seaborn, it's expected that your data structure is going to be a pandas data frame or occasionally a series. So the very first parameter that you typically pass to a Seaborn plot is data. And that's the that is the variable name of the data frame. You can either pass it as the first positional arg or as the quarg, but either way it's mandatory. Most of the functions also have an X and a Y where you specify the names of the two columns that you want to plot. But if you're plotting every possible combination of numerical data columns against each other all at once, like in pair plot or heat map, they're not necessary. There's also a very, very handy hue quarg, which I really like. This accepts a categorical variable, like a species or sex or brand of cars or what have you. That you give it that column name, and what it does is that it splits all the data. It does an internal group by and then plots all the data separately in different colors. Dang, I can keep all these links are breaking. And there's also an AX quarg. If you're calling the data structure as if you're calling Seaborn as part of a larger set of subplots, you can instantiate it as there's figure and axis level interfaces for Seaborn. If you use the usual fig ax equals plot.subplots, you can use Seaborn commands as drop-in replacements, and then you can pass Seaborn an ax quarg where you specify the axis object on which to plot, and then it works like a drop-in replacement. But for a lot of functions, without the ax quarg, the Seaborn plot will take up an entire figure, and for some plot types, that's the only option. That can make the axes labels a little bit trickier to format, but that's okay. It's not that bad. It's just a little tedious. I'll come back to this in a few minutes. So we'll cover just a handful of plot types that are difficult to replicate in Matplotlib. There's joint plot, pair plot, the underlying pair grid function. There's heat map and cluster map, and then I'll do a few types of violin. I'll do the violin plot and related plots because this type of plot is plotting it in Matplotlib gets really ugly and it's just not attractive. Anyway, joint plots. So a joint plot is a plot of two variables against each other with small histograms of the probability distributions of each variable along the top and right sides. If you participated in the Matplotlib seminar, you saw a little bit about how ugly this is to make in pure Matplotlib. But what takes at least a dozen lines of code in pure Matplotlib can be done in one line in Seaborn. So here it is with the MPG dataset. So I've loaded the dataset, and then the joint plot is just this. That makes the entire plot. All you have to be setting the axes labels differently. That's just to correct the that's just to override the default labels. So one thing that's I guess I should go back to this caution. So Seaborn typically titles axes by the variable names as they appear in the data frame, underscores and ugly characters and all. So for proper typesetting, you typically have to override the labels. Which can get complicated in the pair plot version, as I'll show in a couple of minutes. But anyway, here's the example for joint plot. This is all it takes to actually do the plot. Everything you see below is just to format the labels. And this is what it looks like. So I've given it so I've plotted the weight against the miles per gallon. So that's the weight of the car in tons or in pounds and the mileage per gallon. And then I've colored it by hue, or I've colored it by origin, which in this data set is just USA, Japan, and Europe. And so you've got this nice scatter plot that's colored different colors based on the country or economic block of origin. And then you've got this nice histogram on each axis showing how the data are distributed. And as you can see, American cars tend to be heavier and less efficient. The only quark shown in this plot that we didn't cover is marginal tick. Marginal ticks equals true. What that does is that just tells it to show the y-axis labels on these marginal distributions, which are usually omitted because they overlap with some of the data that's down here, and usually they're not that helpful anyway. By default, the main plot is a scatter plot, but you can choose different formats for it based on these different arguments. And if you don't use the hue quark, instead of getting nice smooth kernel density estimations, these will end up just being regular binned histograms. So just so you know how that changes based on hue. What if you have a lot of variables that you need to do this kind of analysis with? The typical approach is to make a pair plot or a corner. The sort of industry standard terminology is a corner plot, where you have sets of plots of basically every pairwise combination of variables that you can, and then on the diagonal there are histograms of the marginal distributions, which are the probability distributions of the individual variables. Seaborn makes this kind of plot super easy to make and customize. And you don't even need to tell it to ignore non-numeric columns. Whoops. For typical data and display settings, it's enough to use the pair plot function. But you can use the more customizable pair grid instead if you want to have like. So let me show the figure first, because it's easier to explain when you actually see what a figure looks like. So for the regular pair plot function, if I pass in here are all the parameters of the MPG plot, just so you know what's there. I dropped cylinders, model year, and name because they weren't helpful, and because I needed to save space. But in order to actually do the pair plot, it's just one line. This temp line here, that's just me getting rid of the columns that I didn't want to show because they're weird strips. Anyway, so the main plotting function is just this. I've selected diagonal kind equals KDE. That just tells it to smooth the histograms on the diagonal. Actually, strictly speaking, that's not necessary since I'm using hue. If I didn't use hue, then it would just be stacked histograms, and it would just look like histograms. But you can force it to make the smooth versions even if you are not using the hue equals origin keyword. So the plot itself you need with this. All of the rest of this code is just formatting the X and Y axis labels. Anyway, so this is what the plot looks like when it's shaded by hue. This is with corner equals true. The default actually is to mirror these scatter plots above the diagonal as well, which is kind of redundant, but if you wanted to do something more complicated with like showing the same data in a different format, you can do that with the full pair grid function. And it'll look like this, and this is the main difference between the pair plot and pair grid is that with pair grid, you kind of initialize the grid itself separately and then map different functions onto the diagonal, below subdiagonal and superdiagonal sections separately. So some of the quarks are the same for pair grid. I encourage you to consult the documentation on pair grid to see what are actually available. But to actually put the data on the plot, you need these, you need to assign pair grid to a variable name and then call .map underscore and then the position of the data. And then in those parentheses, you need to pass a Seaborn plot kind or plot type as an argument. So there's map underscore diag, which handles the data on the diagonal, map upper handles the data above, and map lower handles the data below the diagonal. And each of these takes a standard pairwise plot as a plot type as an argument, and then casts those variables to the respective subplots in the form of that plot. So here I've assigned the same data set to G as pair grid, given the data without the model year, cylinders, or name. I've added this D-spine equals false, and what that does is it draws the right and top edges of each of these squares. And then I also put share diag y equals false, and what that does is that it allows these histograms on the diagonal to expand to fill the entire available area instead of being squished and really tiny in order to match the y-axis of the rest of the row. And then I've had to call map diagonal. Here I've chosen to plot them as histograms, and in order to show the multiple data sets, I've assigned it this stack option. And that basically forces it to draw the biggest histogram in the back and then draw the smaller histograms forward until it gets to the smallest. And that way they don't overlap, they don't cover each other or don't obscure each other. Then this element equals step, what that did is that erased the borders drawn between the histogram bins. So that just makes it a little bit clearer and less cluttered. So here I've decided to use KDE plot as the form for the data above the diagonal, and then show the same data on the lower part as just an ordinary scatter plot. And the other difference is with pair grid is that you have to add the legend separately. But anyway, this is what the result looks like. Sorry, it's a little big. I guess I could zoom out in order to try and show it all at once. Nope, that's still a bit too much. It kind of resizes, I guess. Anyway, I will. So unlike most of the plots demonstrated here, pair plot and pair grid do not have an ax quad because they're already plotting multiple subplots. They have to occupy an entire figure. Anyway, everything else I already said. I didn't go over this in Matplotlib because we had to skip for time, but it is an absolute nightmare trying to produce a heat map in Matplotlib, whereas in Seaborn it's easy. Sometimes you have too many variables to look at with pair plots and coordinate plots. The best you can do is to map the correlation coefficients between different parameters. Or you might have a data frame that actually is kind of has comparable parameters in both the X and Y directions, and you want to see how the rows and columns correlate. Or you want to see sort of the spatial correlation between adjacent rows and columns. Either way, the data frame that is passed to a heat map or cluster map, you must be able to coerce it to a NumPy ND array internally. But once again, in Seaborn, this is one line of code for what would in Matplotlib be a dozen or more lines. So there's a heat map and there's a cluster map. They do essentially the same thing, but what cluster map does is that it rearranges the rows and columns so that those that are correlated are positioned next to each other. The heat map just lists the variables in the order they appear. I can't use the MPG data frame directly, but if I take the I take the correlation of them, what that does is that it just computes the correlation of all the different parameters, and the result of that is amenable to heat map and cluster map. So I've just gone ahead and plugged that in. So taken heat map, mpg.core. Core, again, I have to pass numerical and equals true. Annote equals true, just labels all the different plots, labels all the different squares with the actual values. Formats the values, and then you can pass it different color maps, and for C-bar quarks, you can pass the label of the color bar itself. And the result looks like this. Excuse me. And just so let me see. Oh, that's supposed to be a cluster map. Sorry, I wonder what happened. I guess it lost my edit there, or I didn't save or something. Just so you're aware, there is a bug in Seaborn 12.2 or 0.12.2, and that causes heat map and cluster map with anode equals true to only label the top row. This is fixed in later versions. Don't worry about it. And I'm trying to speed up here. The last kinds of plots that are they're not hard to make in Matplotlib, but they're ugly in Matplotlib, and there's also but there is a couple of similar plots that are like box plot and violin plot that are exclusive to Seaborn, and that's swarm plot and box in plot, which is sort of like it's like a box plot, except it splits it into smaller quartiles and prints multiple boxes. I'm only going to show violin and swarm plots. The Matplotlib version, I don't know if anyone scrolled back through the plot types list in the Matplotlib documentation, but the usual Matplotlib violin plots are visually not very compelling. With Seaborn, you can do lots of fancy things that they look better to begin with, and you can show extra categories with the hue quark. So for these, I'm going to use the Titanic data set. So I'm doing a violin plot of the ticket class, which was first, second, and third. On the y-axis, I'm putting the age, and for hue, I'm putting their survival status. So in one line, I've created this beautiful plot, where you can see the demographics of the age distributions of both the survivors and the non-survivors in each of the classes. So that's pretty. One more thing that you can do that helps save space is that you can use the split quark, and what that does is that it combines these two violin plots in a way that looks like this. And that helps save on space, and it also looks pretty good. It doesn't always print these two little mini box and whiskers separately. Sometimes it does, sometimes it doesn't. I'm not clear on when it does or when it doesn't. There's also a similarly shaped swarm plot, and this is typical, or this is useful for smaller data sets where you might be suspicious that a KDE or box plot might smooth out some important small scale structures. And importantly, this allows you to, although I didn't show it here, this also allows you to show, instead of showing categories that are, instead of showing so with split, you can only show two categorical variables, but with hue here, you can, as you'll see in the examples, you can use a hue that has more than two categories. And the distribution looks like this. Anyway, so key points. Seaborn makes statistical plots easy and good looking. Plot takes pandas data frames and the names of the variables to extract, and often a hue a hue variable that colors different data sets in different colors. And you can play with some of the data sets that are Seaborn offers. The Seaborn data sets, it's worth noting, are also very useful to import for machine learning algorithms. Like if you're playing with scikit-learn or TensorFlow or PyTorch, you'll probably be importing a data set with Seaborn just because it's provided there. Anyway,